Assalamualaikum and a very good day to everyone. In this video presentation for PHY380, we will be focusing on the topic of ultrasonic sensors. This table of contents shows the flow of our explanation throughout the video. Let me walk you through it briefly. First, we will begin with the definition of ultrasonic sensors, where we explain what they are and the general idea behind how they function. Next, we will move into the exploration details of ultrasonic sensors. In this part, we will go a bit deeper into how these sensors operate and what makes them work effectively. After that, we will proceed with some real-world implementation, where we will share how ultrasonic sensors are actually used in various areas of our daily life and technology. Then, we will highlight the potential benefits of ultrasonic sensors. This section will explain why these sensors are widely used and what advantages they offer. Of course, every technology has its own limitations, so we will also discuss the challenges faced in the usage of ultrasonic sensors, factors that can affect their performance and efficiency. And finally, we will end with a section on future innovations. This part will explore how ultrasonic sensors are expected to improve and evolve with time and technology. So these are the 6 main sections of our video. Each of them is important in helping us understand ultrasonic sensors from different perspectives. We hope this presentation gives you a clearer insight into this topic. Let's get started.
Assalamualaikum everyone. It's a pleasure to be here today to talk about what is ultrasound with ultrasonic sensors and its significance. Basically, ultrasound waves are sound waves with a frequency higher than 20 kHz, which is beyond the range of human hearing. Ultrasonic sensors utilize this wave to detect objects and measure distances. They work by emitting a pulse sound and then measuring the time it takes for the reflected pulse to return. This time delay, along with the speed of sound in the medium, allow the sensor to calculate the distance of the object. Let's move to the next part, which is definition of scientific instrumentation. Scientific instrumentation encompasses the tools and techniques used for making precise measurements and observations in scientific research and industry. Purpose, function of the instrument in general. The purpose of instruments is to assist in the performing a task or function, often involving measurement, manipulation, or creating of something.
Next, I would like to discuss about the ultrasonic sensors in scientific instrumentations. Ultrasonic sensors used in a scientific instrumentation for a variety of applications, primarily for non-contact measurement of distance, level, and flow, as well as for detecting the presence and position of objects. Next, I would like to discuss about the exploration of ultrasonic sensors. The first one is collision avoidance.
In automotive safety systems, ultrasonic sensors assist in collision avoidance by detecting nearby objects and providing warning or assisting with parking. One or more ultrasonic sensors are placed at the front, sides, and back of the robot or vehicle. Sensors constantly emit sound wave, usually 40 kHz. If a sound wave hits an object, it reflects back and is received as an echo. Next, number 2 is ranging measurement. The sensor periodically measures the distance of one or more objects moving toward or away from it during each time of flight cycle. The update rate of these distance readings depends on the duration the sensor remains in echo listening mode. A longer listening period allows the sensor to detect objects at greater distance. Next, it is tank level monitoring. To accurately measure the level of a liquid, water or oil, or bulk solid inside a tank without physical contact. An ultrasonic sensor is mounted at the top of the tank, facing downward toward the surface of the liquid or material. The sensor emits a high-frequency sound pulse. The pulse levels through air, hits the liquid and solid surface, and then it is reflected back as an echo. The sensor measures the time it takes for the echo to return. So, the distance and liquid level can be known by calculation.
Hello everyone and welcome to NTech. In this video, we will see how to make a radar using ultrasonic sensor. When there is no object in front of the ultrasonic sensor, there are only green lines on the radar. And now when I bring an object near the sensor, the portion which is covered by the object is indicated by red lines on the radar. To build this project, we will need an Arduino Uno, an ultrasonic sensor, and a servo motor. Let's begin by connecting all these components together.
Next, the example real-world implementation ultrasonic sensors include oil and gas industry. The next one is automotive systems and smart waste bin monitoring.
Next, I would like to discuss about the example real-world implementation of ultrasonic sensors. For the first one, mostly ultrasonic sensors used in oil and gas industry. So it can measuring or remaining water or chemical in tank. So it can prevent overflow or dry run and automate refills. The next one, ultrasonic sensors can be used in parking assist systems or automotive systems. So car can detect proximity objects while reversing. So it can prevent minor collision and improve safety. And the last one, ultrasonic sensors can be used in smart waste bin monitoring. Ultrasonic sensors inside bin and measure all the filth levels.
so it can optimize collection routes in smart cities.
Okay, potential benefits of ultrasonic sensors. These are a few ultrasonic sensor advantages that help clarify what applications our sensors are suited for. First, not affected by color or transparency of object. Second, can be used in dark environments. Third, affordable and compact. And last one, strong anti-interference ability. Okay, first, not affected by color or transparency of object. Okay, because ultrasonic sensor is reflect some of object, the object, so the color or transparency of the object will not affect the sensor's reading. Second, can be used in dark environments. Unlike proximity sensors using light or cameras, dark environments have no effect on an ultrasonic sensor's detection ability. Third, affordable and compact. Low cost and small size make them suitable for embedded and mobile system. Last one is strong anti-interference ability. It is very resistant to environmental influence and can be used in any lighting environment. It has reliable performance in a variety of light settings, including indoor, outdoor, and complex ambient light. Because ultrasonic transmitters are not affected by smoke or dark matter and can detect light, smoke, dust, color, materials, and others. They are superior to infrared sensors in a variety of applications. Okay, next, challenges of ultrasonic sensors. First, cannot work in a vacuum. Since the sensor rely on sound to function, it cannot function in a vacuum because there is no air for sound to travel through. Second, not suitable for use underwater. Do supply documentation for customers who could still like to test our sensor underwater. Third, strong anti-interference ability. Standard longest range sensors have a maximum range of 10 meters. Now, cargo sensor detects up to 16.5 meters. While this is disadvantageous in certain applications, our sensors have great mid-range capability and are still suited for many applications. The last is soft material will have an impact. Objects wrapped in soft fabric will absorb more sound wave, so it making difficult for the sensor to see the target. The last one is future innovation ultrasonic sensor. First, improve range and accuracy. Advance in sensor technology and signal processing will improve the range and accuracy of ultrasonic sensors. This can enable robots to operate more effectively in a wider range of environments and perform more complex tasks. Second, multimodal sensing. Ultrasonic sensors work well with other technologies like LiDAR, radar, and cameras. Light combination helps robot collect better and more accurate data about their surroundings. This can improve their ability to navigate, detect obstacles, and perform various tasks. Third, advanced, advanced signal processing. As ultrasonic sensors produce more data, we need better ways to process this information. Advanced signal processing algorithm will play a key role in this. This algorithm can help to filter out the noise and extract meaningful information from the sensor data. The last one is miniaturization. As technology advances, ultrasonic sensors are becoming smaller and more compact, enabling their use in more miniature agile robots. This trend will likely continue with HCSR04 ultrasonic sensor becoming even smaller and more versatile.
To conclude, ultrasonic sensors are very useful in many real-life applications. They can help us measure distance, avoid collisions, and monitor liquid or solid levels in tanks. One of the big advantages is that they are small, affordable, and can work even in dark environments. However, there are some challenges. Ultrasonic sensors cannot work in a vacuum or underwater. Also, soft materials may not reflect the sound wave properly. Looking ahead, we can expect ultrasonic sensors to become smaller, more accurate, and more advanced. They will also work together with other sensors, for example like LiDAR and camera, to make systems even smarter. So, ultrasonic sensor will continue to play an important role in the future technology. Thank you.